Okay, so we're going to get started here. Buenas tardes. Buenas, okay. People are awake, at least. That's good. Well, so I have a couple of apologies to make right off the bat before I even introduce myself. And that one is we've got little time to work with, and we have a lot to go through, and it's all in English. So for those of you who are Spanish first or Spanish only, lo siento. I will try to be as succinct as possible, but I am a bit of a motor mouth. I speak fast, especially in this deck, and it's normally an hour-long presentation, but hopefully it will leave you with a lot of interesting things, interesting leads to follow. And so, transitioning into the presentation itself, I'll say this. Please, if you think there's any chance you might want to get in contact with me after the presentation, take a picture of this slide, or I'll throw up a similar slide with this contact information at the end of the presentation, because I don't have cards, and it always goes like this. After a talk, after I say this, there's still a few people who came late or didn't take a picture because they thought it was going to be boring, and then they were interested. And then I end up putting my hands all over everybody's phone, and it's very awkward for everybody and shouting out contact information, etc. So yeah, please take a picture just in case. I'll throw it up also at the end. So my name is Michael Ludden, and I run a team called Watson Developer Labs, which I started, and we have as part of our mission an initiative called AR/VR Labs. Our overall mission and what we do is to create products for developers that solve use case-based problems they face with IBM technologies. Sounds like a lot, but it actually means something, and that is an example of what we do would be the Star Trek Bridge Crew with Watson integration, not the integration itself, but the sandbox that powered the integration. So I always like to kick off the talk. So it's about the intersection of artificial intelligence and virtual reality, and to sort of ground it in an example, this is why I sort of go through something that's familiar to me, because obviously our team did it. It is an example of AI in VR, and then we're going to move quickly on to a lot of very interesting things that I have a lot to say about, and so I'll try to make this quick. So just to sort of ground the whole presentation, I'd like to start off with a character-narrated overview of Star Trek Bridge Crew, which is a game that was launched earlier this year that's the first of many kinds. It was the first VR-only experience that was a licensed property. It was the first time there has been a Star Trek game in VR, a first time you could talk to Star Trek people with your voice in VR, all sorts of things. So without further ado, let's play the video. And, pay special attention to LeVar Burton. He's the host. Does anybody know who LeVar Burton is? Reading Rainbow? Geordie LaForge, yeah. He's also, turns out, a bit of a hype beast. So here we go.
Limits and to prove her place among.
This is actually not really about anything related to the voice interaction system that we put in. This is just to sort of ground you in what the game's about and how you play it. And that's going to come into play later.
Captain's log. Stardate 2016.165. Starship USS Aegis is preparing for her maiden voyage. We've gathered some of the most decorated officers in the Federation to test her limits and to prove her place among Starfleet's finest ships. We're en route to a secret testing facility and are proceeding to our destination at maximum warp. This is amazing!
Wow! Absolutely astonishing.
When I walked in, I really wasn't sure what I was actually walking into.
This is very cool.
If I could have imagined what I would have wanted the Star Trek VR game to be, this is it! This is what we've been waiting for.
Holy crap, this is amazing.
I mean, it really is breathtaking. That was an extraordinary experience, to be fully encompassed in a world.
Whoa, not into that. You're interacting with each other, and you're talking to each other, and you're taking
7 of
orders from the
9,
captain,
anybody?
and you're, I mean,
Star Trek
it's
Voyager?
really cool.
So there's captain, helm,
Yeah.
piloting the ship, tactical, and the engineer routing power and charging warp coils.
I'm feeling pressure already. I'm feeling nervous now.
All right, shields up.
Prepare warp. Take us out.
Yes, Captain.
Co-op game playing is not new. I mean, you know, we can play games with our friends, but there's something
Wow.
different about being in a shared virtual environment.
Hearing who you're playing with, you can look over and see the person and see them doing their job and talk to them.
The team does not succeed unless everybody does their job well.
Ship decloaking, activating shields.
Okay, shields up.
Shields up.
I really did not want to lower the shields while we were under attack. I was very impressed by LeVar playing that game today. He really had the language of Star Trek down.
And they are transporting, Captain.
It was like, yes, yeah, this makes you push the buttons.
I will say I nailed being the engineer.
Hype beast.
That doesn't sound good.
It's a Klingon. Red alert.
Preparing to warp.
We're under attack. We have been waiting in anticipation for so long for the technology of virtual reality to catch up with where we imagine we should be and where we all want to go. Line us up for warp, please.
We have full power.
Ensign, as soon as you can get us the hell out of here, I'd be most grateful.
This was really incredible.
Hull is down to 20%. Come on, y'all.
Punch it.
As soon as you can. Here we go.
Woohoo!
It's your own Star Trek experience in a virtual world where you can hang out with whoever you want. And that's a pretty good deal.
You know what? That video, normally I have to comment on how cheesy it is, but it feels a lot less cheesy on like a giant IMAX screen and with this sound system, right? Okay, anyway. So that's Star Trek Bridge Crew. It's a first of its kind. It's a genre that's been established and is very popular amongst a certain small niche crowd, but they've always wanted an officially licensed Star Trek version of this, and VR is kind of like the kicker, like, oh my gosh, I can actually live this experience, so it becomes much more role-playing in nature. And it's turned out to be very wildly popular and have a lot of staying power, especially when you consider that it's a VR title and that's a very young platform. So enter IBM, and instead of myself trying to explain what the VR speech sandbox is, how we kind of approached Ubisoft, who created the Star Trek Bridge Crew game, with the opportunity, how they integrated it, and really who it's actually for. But I can do it a lot more succinctly in this video than I can standing here. So there's a 90-second video to describe the VR speech sandbox and also how it got integrated into Star Trek Bridge Crew. And that is your example for AI in VR.
So early in 2016, when the Vive and the Rift, Oculus Rift, were coming out, I noticed that all of these VR headsets, including mobile ones, were coming out with microphones in them, but people weren't taking advantage of voice interaction. And I also realized that voice interaction makes a lot more sense in VR than it does other mediums, and we actually have a really ready-made solution in the form of Watson. And so we put together the VR Speech Sandbox to basically make it easy for developers to build their own voice interaction systems from virtual reality. And in the demo, what you can do is you can create, modify, and destroy objects only with your voice. You can say, create a big black dragon, create a small blue car. You can also use variants, like, give me a big black dragon. You don't need to use a wake word. It's very natural. It accommodates for errors. And at one of the first shows we showed it off at, VRLA in 2016, Ubisoft was there. And I approached them because I'm a big Trek nerd. And long story short, a little over a year later, they are actually building a feature which is based on the work we did for the VR Speech Sandbox. We're really happy to get that into the hands of players, and we hope that sparks interest among developers to check out the VR Speech Sandbox.
So for those of you Spanish native, I apologize for the lack of subtitles on that video. Essentially, what we're talking about is this. So the VR Speech Sandbox is now a toolkit for multiple devices, basically making it very easy to add a robust and configurable interactive speech engine to any virtual or augmented reality experience. Right now we support HTC Vive in Unity, Google Cardboard in Unity, and Oculus Rift in Unity. We are starting to support and will release very, very soon Unreal for HTC Vive, Samsung Gear for Unity, eventually Unreal as well, and Google Daydream for Unity, and also eventually Unreal, and then Oculus Rift for Unreal. All of this in the next 2 quarters, and then we're planning to productize it even more, do things like, we have on our roadmap broadly to add a front end, make it really easy for developers to select the version they need. But the whole point of this solution, to kind of illustrate the work that our team does, is to make it easy for AR and VR developers to do something they couldn't do before in a way that makes sense for IBM to engage. Well, it just so happened that we had a ready-made platform that was very potentially useful in a new scenario that had never really been considered, and that's that virtual and augmented reality devices all have microphones, every single one. Most people aren't taking advantage of voice experiences right now in those experiences for the most part. And could we use our cloud platform, which we'll get into in a minute, which contains a lot of AI solutions under the name of Watson that developers can take and use as APIs, make it really easy to make a drag and drop kind of situation, at least to start with, for Unity developers. And for those of you that don't know Unity, Unity is the most popular development engine right now for virtual and augmented reality apps because it's very easy to get started and prototype. But Unreal's hot on their heels as well. So if you're interested, take a picture there. It's free, it's open source, it's in GitHub, all versions. You can take and fork and use to your heart's content. The whole purpose of the integration with Ubisoft, which I explained in the video how that happened, was to get all this free press, but very specifically say, hey, Ubisoft did this, but they did it with a solution that's the exact same thing you can use for free today. So it was meant to be an idea starter, to ground people in the possibilities, but also to ground us as thought leaders in the space. And I think it's having that effect. So that is one quick example of AI in VR. Now we're going to switch gears Oh, and by the way, if you want to learn more about that, Respira. Hate sites that autoplay videos. That needs to stop. And I know Google's going to kill that in the next version of Chrome, so that's great. So yeah, this is the best article, I think, if you want to just go into the details, and you can stomach reading English, although I'm sure there's a great Spanish translation of it, from CNET. Just Google it if you're interested in learning more about that. And then last plug here, the demo in the video. If you want to download that, and you have an HTC Vive, you can. It's free. It lets you create, modify, or destroy objects with your voice. You can also compile any of our Git repos and do a very pared down version of this. But it's not meant to be us saying, look at all this content we're doing. It's meant to be us saying, hey, here's what you could do, hopefully better, yourself. But it highlights things like you don't have to use a wake word. You can just say, make a big black box, put a small blue dragon there, make 3 big cars or whatever, and have that happen. And it's meant to highlight the extensibility. Okay, so switching gears pretty drastically, let's talk about artificial intelligence. Okay, so there's a lot here. I have a lot of pet peeves around the use of AI terminology, and I'm sure pretty much everyone in this room probably does already as well, or you're developing it. Actually, you know what? I'm pretty sure everybody at this conference has a pet peeve with how people use the term big data, because it's become very nebulous as a term, in the same way that cloud has, or synergy, or whatever other buzzword you want to throw around. And artificial intelligence is starting to get, well, not starting to. It is absolutely getting used and abused for every purpose under the sun. So I think it's useful, before I go into the details of AI in VR and get into some of the more interesting parts of this talk, with the time that we have, to kind of define for the purpose of this talk, and also set out a framework that I hope people will use to be more specific and be able to be talking about the same things with each other when they talk about AI and related terms. So I'm gonna use the example of AlphaGo in this case, because I'm really excited about some of the developments there. Is everybody here familiar with AlphaGo? Or is anybody? How about AlphaGo? Yeah. What's AlphaGo? Who's brave enough to shout out and answer? That wasn't really a shout, but yes. Thank you. Thank you. A machine learning algorithm that plays Go. And what is Go? Someone, shout it out. It's a board game. Yeah. I mean, it's not like the game of life or anything. It's a little more complex than that. But yeah, it's a board game, yeah. It's an ancient Asian game that relies on intuition and strategy to defeat an opponent because there are simply too many moves for there to be a mathematically correct choice. So it was thought that it would take machine systems a lot longer to actually conquer that than something like chess or even Jeopardy, which, as you know, IBM has a history of creating, solutions that will attack those problems. So we did Deep Blue in the 90s, and then we did Jeopardy with Watson. That's kind of the genesis of Watson as the brand, as the platform. But Go was considered another beast altogether. Well, Google created a machine learning algorithm that actually was able to consistently defeat the world's best Go players. And this happened last year. And I think it beat the world's best player earlier this year, 2 out of 3 times or something like that, I think. But what's really interesting to me, and I was interested in AlphaGo, but to me it's just more of kind of the same idea, right, with a little more complexity layered on. Like, okay, we're making progress, good. AlphaGo Zero is really, to me, something different. Has anybody heard of AlphaGo Zero? It's not like Coke Zero. This is a Coke Zero can. I don't know if it's branded the same way here, but in the United States, Diet Coke is essentially, there's 2 versions of it, right? There's Diet Coke, which some people like, and they brand it to certain people. And then there's Coke Zero, which is the same thing essentially. It has 0 calories, but that's branded to a more macho crowd, so I just think it's funny. It's like Coke Zero. I don't like Diet Coke. I like Coke Zero. I'm a man. It's just really silly. But so I use this because AlphaGo Zero is like AlphaGo Lite. It's like zero data input algorithm. Oh, actually, for this audience, you may be very concerned by this because the interesting thing about AlphaGo Zero is that it required 0 data in order to achieve its results. So I'll go into that in a second. First of all, if you want to learn more, definitely read that article by The Guardian or any other really about AlphaGo Zero. AlphaGo Zero is a new version of AlphaGo that beat the old version of AlphaGo, which was already the best Go player in the world, de facto, 100 times out of 100. It was trained in 3 days, without any data input. Think about that for a second. The previous version of AlphaGo was trained on all of the best moves from all of the best players and all of the best strategies for Go throughout all of history, right? So it was biased, essentially, based on that data. And all it did was, what some of the watchers observed was that it iterated on the strategies of those that preceded it, just like every human's ever done, right? When you play a great game, when you play basketball, when you play any game, all the great players, unless they've changed the rules, essentially add their spin to existing techniques, right? It's very hard to do something else. AlphaGo played itself only, using the parameters it was told about the game, and developed its best strategies to defeat its other versions, and the master version of AlphaGo Zero then took on AlphaGo and beat it 100 times out of 100. The interesting thing about this is that, these headlines are like mind-bogglingly ostentatious, but at its core, essentially what it's saying is, hey, you don't necessarily need data to train algorithms to do things better than humans, even advanced and complex things that require human intuition, human-level intuition and strategy. And this is significant for any number of reasons. But I can't go into those because I don't have a lot of time today. But I think it's fascinating. I definitely recommend you look into it. It's blowing my mind, and I love having conversations about it because I happen to think it's a game changer. But we can draw several things from this example in terms of AI terminology. First of all, AlphaGo is a machine learning algorithm. When we're talking about artificial intelligence, for the most part, we are actually talking about machine learning algorithms. That's basically algorithms that are trained using various techniques. One of them would be incentivized learning. In the case of AlphaGo, it's incentivized learning. That means that it gives it a cookie, that, whatever the version of that is, like a thumbs up, a pat on the back when it does what it is supposed to do, what it's been told that it's supposed to do. You need to get more points than the other player in AlphaGo. for example, and then that's incentivized learning. And when it does that, it gets reinforced. It gets its version of a dopamine level dose jolt. Its reward center lights up or whatever. So anyway, an algorithm is basically what allows well, I don't think I need to get too reductive with this audience. You're all very astute. So it's essentially the rules-based system that allows it to function at a very, very high level. But when people talk about artificial intelligence today, especially outside of technology circles, I think a lot of people are thinking general AI, but what they actually mean is narrow AI. So I'll give you an example of narrow AI powered by a machine learning algorithm. So on your phone, if you take out your phone and you have an iPhone, which I don't, I have a Pixel 2, but you say, hey Siri, set an alarm for 4 p.m. tomorrow. Siri will do it, right? That's an example of narrow AI. It's a number of algorithms parsing everything from your speech, translating that into text, parsing the meaning of what you're saying, checking that with its own systems and subroutines, checking back to call home to see what the right action is to take, and then it's going to, based on a bunch of rules, do the thing that you said, right? But general AI would be if you said, hey Siri, make an appointment for 4 a.m. tomorrow, and Siri said, whoa, whoa, whoa. I told you never to talk to me after 9 p.m. I need my beauty rest. I need at least 9 hours of sleep, so please leave me alone until tomorrow. I'm trying to learn painting, and I can't get enough rest to take on that new challenge, if you keep bothering me after 9 p.m. I think we talked about this. Now, why is that general AI? Because that would be the machine learning system having agency of its own and deciding what it wants to do and when and why, right? Having its own intrinsic logic and motivation, and its own ability to go after, ooh, that's new. Oh, my computer just died. This is great. This is wonderful. This is absolutely perfect. Okay, 1 second, folks. Talk amongst yourselves. Pretend this is Justice League up here on the screen, not just blackness. It's kind of similar. Thank you. In the speakers lounge, a bunch of us had our laptops plugged in, but none of us noticed that there was no power. And so about 1 minute before I had to come here, they're like, oh no, the power's off. Okay, so that's just making an excuse, basically. Should have had it charged last night. Other side. Thank you, sir. Okay, so some people refer to the advent of general AI as when machines will gain consciousness. I mean, I don't think that we're even, at a place where we can confidently assert a definition for consciousness, or even that we are conscious beings. So don't want to go into all that. We don't have that much time, but it's quite an interesting and fascinating discussion. I tend to say that the differences are best explained with examples like this, right, of the major difference. So you wouldn't ask the AlphaGo 0 algorithm about dating advice currently, because it doesn't understand anything about it, nor could it create the knowledge for itself and a structure in which to think about that in order to give you that advice on demand. If it could do that, we'd be at general AI. There are a number of attempts to bootstrap general AI, which is, the singularity would be the inflection point at which general AI occurs. And the singularity is something I'm very interested in, but as with many things, we don't know when it will happen. We don't know if it's already happened. I think it's Arthur C. Clarke who gives the quote, "The future is already here, it's just not evenly distributed." So I think that, it could have already happened, and it's very likely that it will happen in our lifetime, but we just simply don't know when, and also, importantly, we're very far from that in the way that we talk about AI right now. Cognitive is another buzzword term that IBM, Microsoft, and some others like to use. It's basically synonymous with artificial intelligence. Machine learning as a service, just an acronym, it's helpful to know, and on and on. So, moving on, assuming I can. There we go. Okay, so current approaches to artificial intelligence. Cloud-based, we do that. Google, Microsoft, Amazon, others, basically making our algorithms available to developers as APIs. Hey, you want to do speech to text, transcribe what somebody's saying to text very well. Okay, go ahead and use our service here. Many people are also doing local algorithms, meaning doing their own, which if you're a company and you build your own machine learning algorithm, you could certainly make that available to people as an API down the road. Cafe and others are also available in addition to TensorFlow. Importantly, TensorFlow is not Google giving away Google's secret sauce. It's Google making a really great tool and some helper libraries around that, just like some other really great tools like Cafe, et cetera. That allow you to train your own algorithms, but they're not showing you their neural nets. They're not giving you their incentivized learning structures that yield their amazing results for what they use in Google Photos to let you search for your dog, et cetera. No, so you have to build all that stuff yourself. But I think Google's strategy is really, really smart because people will automatically associate the two. And so I actually commend them for that strategy, although I hope they don't lean into that misinformation. Open source is my favorite. It's also the least popular right now amongst big companies because it's a longer play, but I think it's also really great. It's also, really, really virtuous in a number of ways. So H2O.ai, Algorithmia, et cetera. There may be a few companies here showing off similar solutions. They all operate on this notion of we're going to build machine learning algorithms like computer vision things. We're going to offer them for free, but you're going to get the most benefit if you use our solution services, which will make it very easy for you to integrate them and do the most things with them. But importantly, you can always take and fork anything they have on the internet, so that's great too. GPU accelerated is just to say that NVIDIA and others have created tools like CUDA that allow you to train faster on their GPUs. I recommend you take advantage of those if you're going to build your own locally based algorithm. But I'm going to talk about the benefits and drawbacks quickly of each. So cloud-based, easy to implement. It's just API calls to get any number of, so for us, for the Watson Developer Cloud, it's 14 different services. They're all APIs. You can use them to do things like analyze images, parse text, understand the meaning of what people say, translate languages, document conversion, data insights, etc. There's low ongoing maintenance cost, and you get advanced functionality out of the box. Local algorithm, obviously you own it. You can build it and have your own roadmap, which you control, and the features that you build can be tailor-fit to exactly your needs and nobody else's. And then it's also offline capable. So for cloud platforms, you need to be able to check in with the internet every so often. Offline capable, there are a number of scenarios. Embedded devices are an example. Things happening in space. I've heard of NASA using TensorFlow to build a very basic speech recognition system because guess what? There's no internet in space yet. Anyway, those are some scenarios of why offline capable is important in certain things. Open source is the best of both worlds, but it's important to notice that for cloud-based, yes, you get advanced functionality out of the box, et cetera, et cetera. It's cheap, it's free to prototype, but you're beholden to another company for all of that functionality. You always will need an internet connection because it's cloud-based, and services may not be tailor-fit to your needs. In fact, and I need to add this onto here as a bullet point, a company like IBM could say, you know what, there's only 3 customers using this one feature, we're going to kill it. You could be one of those customers and you could have your whole business based on it. So you got to take those things into account. For a local algorithm, people really don't give this enough credit. Lengthy time commitment and person commitment. Maintenance cost only grows over time. Well, yeah, I'm not telling you guys this, right? What's interesting to me is if algorithms like AlphaGo take off, you may not need as much data input as you did previously. I have 32 seconds, right? 30? Yeah, okay, good. Okay, we're gonna go 5 minutes over because I was 5 minutes late, and then give you a 5-minute break. So there we go. Okay. So in terms of here's the other thing. You're also going to get much more basic functionality right out of the box. And I would say if you're a company considering AI solutions, it's free to prototype with the cloud-based solutions, so you should do that automatically. You should also probably investigate if it's possible for you to do your own machine learning algorithm in-house for the long term, because if it is, then you should, because it's cheaper and you control it for all the reasons we said. But that's a big if. And also, you got to you got to think about your competition, right? So if you are making a photo sharing app and you're trying to compete with Google Photos or another company like that, and everyone's used to being able to search for, like I said, photos of their dog and have their dog pop up, you're not going to be able to build that functionality overnight yourself. So if you're going to compete on that feature and that's your business decision, well, you may need to use Google or you may need to use a competitor, that kind of thing, right? So it's all about picking your spots. And then also understanding that your customers are going to expect improvements over time, right? So they're not just going to be happy with the way things are today. They're going to want it to improve. And that means ongoing maintenance costs. So open source is also kind of the worst of both worlds in that sense. All right, so this is the worst slide in the world, the worst chart, but it basically is saying time to value is much faster with a cloud-based service. Trade-off is control. And it's much slower with offline capable local algorithms, but you do get other benefits there. All right, so AI and VR. This is really the fun part, and we got 5 minutes to talk about it, or how much now? 4, 3, 4. All right. So it's okay. You can laugh. Laughter is a good thing. It's a good thing. We need you guys to wake up. Gosh. All right. So current trends that I'm seeing, because companies approach us a lot, because we're doing a lot more than just the VR speech sandbox in the AR VR space. We have, like I said, a whole initiative. I've got one of my product managers running this entire thing. We've got a lot of things in the works. So companies come to us and they say, hey, we want to do this, we want to do that. Obviously, a lot of people come to us for interactive speech interfaces, especially for non-gaming entertainment use cases like therapy, education, training, recovery. Visual recognition, a lot of companies are looking for heat maps and kind of analytics around VR, but a lot of them are missing a key element of VR, which is that if this scene was in VR, for example, and I wanted to know, what's this person's height or the distance between me and him or how long was he looking at me, I don't actually need a visual recognition tool to tell me that. It's in VR. Like, it computationally knows all of these things, where the eyeball sprite is looking and for how long and the exact distance, right? So there are a lot of things that we need to rethink our capabilities about because there are more of them in VR and AR than we currently have. And so I'm going to get into a number of examples of where this requires thinking. We're still in early days, and that, to me, is incredibly exciting. But for my money, most of the companies looking to leverage visual recognition are thinking in the wrong way, because visual recognition, like our visual recognition tool, would maybe pull an image from one of the 2 eye images, a flat 2D image of a scene, analyze that image, and tell you things in it. And to me, that seems like reinventing the wheel unnecessarily. So data analysis and manipulation, there is a lot of movement here around a lot of people are recognizing that spatial memory in humans is really powerful, and we can engage it in VR in ways we never really could before. And so when you think of plotting data on an immersive sort of three-dimensional flat surface where people can look at it from multiple angles, actually allows people to see and intuitively understand anomalous data points and what they mean in a way that is very, very different from looking at even a 3D model and rotating it on a computer screen. There is something about our spatial memory. I'll get into that more in a second. So spatial programming. Visual programming interfaces are when you string nodes together, and it essentially says you can prototype with very little code being touched. Spatial programming would be if I were in a virtual scene and I put a node here and I put another node here and I connected them together and there was an architecture, and maybe that's my speech recognition stuff. And then over here I've got some other stuff here and I connect the two, and that's the data feeding the two. Something about the spatial relationship between the two will help my mind keep it distinct, that this is this architecture over here and this is over here, in a way that simply scrolling on a 2D screen doesn't. I'll give you one quick example from, has anybody seen Sherlock Holmes, the show, yeah, with Benedict Cumberbatch? Has anybody seen the episode where he talks about the Mind Palace? The Mind Palace? No? Anyway, he's got a Mind Palace, and that essentially helps him to remember things. Mind Palace is an ancient Greek concept that that's a tool that allows any human, including you here, to engage their spatial memory to remember things that they're having a hard time remembering. In my case, names. So what you do is you pick a familiar place, in my case, my apartment, and you pick some spots, right? So you can pick 6 to 12. Let's just go through 5. So I've got my shoe rack on the right, I've got my guest room, I've got my balcony, I've got my guest bathroom, I've got my my refrigerator, and that's enough for now. So as I walk in, because I want to remember names, let's say my maintenance manager, right? I never remember his name. His name's Jeff. I remember it now. I put him on my shoe rack, and I have him screwing in a light bulb, and I have him turn to me, and he says, F. Something he would never say. It has to be a jarring behavior that they do, and that makes you remember it. And F means he's frustrated, right? And he doesn't swear, but it also reminds me that his name is Jeff. So he's holding up a J in his other hand. So it's J and then F, and now I've never forgotten his name. So every time I see him, I freak him out because I'm like, hey, Jeff, how you doing? Where before I was like, hey, you know. So anyway, it's really powerful, and I think it's worth looking into. NPC replacements, the games industry approaches us for that all the time because AI routines are something they've been running for years, but when they say AI, they don't actually mean AI, so there's a lot of disambiguation there. Future trends, wow, so much good stuff I didn't get to cover here. You know, honestly, the crux of it is AI in VR is going to be transformative, mostly not for gaming and entertainment purposes, but for everything that comes after, which I think are going to be the most important, most used, most monetized, biggest businesses for AR and VR, and that is productivity, therapy, education, recovery, and training. Unfortunately, I don't have enough time to get into any of that, so I'll just leave this slide as kind of like a tease. And you guys can interact with me after the talk, or, like I said at the top, I don't have any cards, so please take a picture of this slide if you think you might want to get in contact with me and you're not able to, reach me today. So thank you guys very much for your time. Have a great day.